Good morning student, welcome to your computer class. In previous class we have already discussed about the hardware components in computer. So in this uh, chapter, in chapter number 2, we are going to discuss about introduction to number system. So the computer system comprises of hardware and software. We have already discussed that a computer works with the help of hardware and software work together. So when we type a character, that is letter, digits or special character on the keyboard, the computer converts and stores it in the form of strings of zeros and ones. So the symbol 0 and 1 are together called binary digits or bits and form the binary number system. So the memory of the computer can be thought of as a vast group of cells. As we know that human body is a group of cells, in the same manner memory of computer also is a vast of group of cell, and 0 and 1 are the binary digits or bits. So computer works in the binary number system. So each of these cell contains one bit of information, that is each cell contains 0 or 1. In this chapter we will learn about the what is hardware, what is software and storage units in computer. Then we will discuss about the number system and we will also discuss about the conversion from decimal to binary and binary to decimal system. So we here is also the octal and hexadecimal system. So let's start the hardware. So what is hardware? Hardware comprises the physical components that makes up a computer system. So we have already discussed about the different types of hardware components used in computer system, that is it can be internal or it can be external. So example of internal hardwares are the motherboard, CPU, hard disk, disk drive, SMPS, etc. And the external hardwares are input, output and storage devices. So input devices are, we have already discussed that keyboard, mouse, and output devices are printer, monitor. Storage devices are pen drive, hard disk, etc. And the internal hardware is motherboard, CPU, disk drive, SMPS, RAM, ROM, PCI, etc. So in so what is next is software. So software is a set of computer programs and procedures that provide instruction to the hardware on what to do and how to do it. So a program is a set of instructions that perform a particular task. So we say that software is a set of computer programs and procedures that provide instruction to the hardware on what to do and how to do it. So with the command of software, hardware works. So a program is a set of instructions that perform a particular task. The two types of softwares are system software and application software. So system software is a set of one or more programs that is designed to control and manage the operation of a computer system. So the system software works as an interface between the hardware and the user. So we can say that system software is mainly the interface of hardware and user. So example of system software includes operating systems, device drives, language processor, etc. So then application software. Application software comprises computer programs that is designed to help the user in performing a certain types of works. So as we all know that many types of application we use in computers to do some works which are not fixed in systems. So we externally download it and run it in our computers to do some special works. So application software pertains to one specific use or application. So examples of application software includes general purpose software such as word processor, spreadsheet software, and special purpose software such as payroll system, inventory system, and accounting system. So this is the concept of hardware and software. After that, we are going to discuss about storage units in the computer. So in computers, storage units are can be bit, byte, nibble, and words. So what is bit? It is the smallest data unit in a computer, so which contains a single binary value 0 or 1. So a combination of bits is used to store information and data in the computer memory. We have already discussed that computer works in binary system. It contains only 2 digits. These are 0 and 1. So a combination of bits is used to store information and data in the computer memory in the form of binary system, that is 0 and 1. So the combination may be a byte, a nibble, or a word depending on the number of bits it can store. So what is the smallest data unit in a computer? That is bit. Okay, the next is byte. A combination of 8 bytes forms 1 byte. Okay, so a combination of 8 bits. Bits is the smallest data unit, and the combination of 8 bits form 1 byte. So each byte represents one character such as A, B. It can be small a, small b, 1, 2, etc. 1 to this. So nibble. A nibble is a group of 4 bits. It can store one decimal digit in its binary form. Then word, a group of bits representing data or instruction that forms the basic information units of a computer is called word. So a group of bits representing data or instruction that forms the basic information unit of a computer is called word. So it is a group of fixed number of bits processed as a unit in a single operation. It varies from computer to computer but is fixed for each computer. So a computer stores information. So a computer stores information in the form of words. A word may be of 8, 16, 32 or 64 bits. Okay, so word may be of 8 bits, 16 bits, 32 bits or 64 bits. Byte can be 8 bits. Byte is formed with 8 bits. Nibble forms with 4 bits, and word can be formed with 8, 16, 32 and 64 bits. Okay, so a machine with 16 bits word is slower than one with 32 bits word. So the size of a word depends on the architecture of the computer. So the length of the computer is called word size or word length. The other storage units in the computers are kilobyte, KB. We already know that KB, MB, GB, TB. It is used in storage devices. So KB means the kilobyte, which is 10 to the 2 to the power 10 bytes, means 1024 1024 bytes. Megabytes is actually 1024 kilobytes. Okay, so megabytes is 2 to the power 10 kilobyte, means 1024 into 1024 bytes. In the same manner, from kilobyte to yottabyte, it will multiply it with 1024 in every steps. So at first kilobyte, then megabyte, then gigabyte, after that terabyte, then petabyte, then exabyte, then zettabyte, then yottabyte. So these are the storage units in computer. So if we ask you that what is the storage of gigabyte, you can say that gigabyte means 2 to the power 10 megabyte, or 1024 into 1024 into 1024 bytes. So these are the storage units of computer. I hope all of you have understood the storage unit in the computer system. So next is number system. So in digital representation, the most common number system used are binary, decimal, octal and hexadecimal. So we'll briefly discuss about this. So what is decimal number system? The decimal number system is what humans use most commonly. That means 0 to 9. So the decimal number system is 0 to 9, means it contains 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you count 0 to 9, you will see that here is total 10 digits. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 digits. That's why it called decimal number system. So using this decimal number system, we can represent a number. So using these digits you can express any quantity. It is also called the base 10 system, basic, because it uses 10 digits. So decimal number system is most commonly used by us. So the base number 0 is also called the radix. Okay, so the decimal number system is a positional value system, also called the place value notation. So decimal number system is also called positional value system. If we take 256, you can see that here they take in 256 as the decimal number system. So the position of the rightmost digit is the ones position. Means you can see when we put 256 in decimal number system, the rightmost digit is 6 and it is at ones positions. Ones positions mean 10 to the power 0. As all you know that 10 to the power 0 means 1. So this is the ones position. So the numeral in that position indicates how many ones are represent in the number. Okay, so here in this case, in this number 256 to 256, the ones positions represent 6 ones. Okay, so the next position to the left is tens, means 10 to the power 1. 10 to the power 1 cell means 5. So this is the 10 position, so it contains 5. And next is 100. The rightmost, the leftmost is 100th position, so it contains 2. Okay, in this number system the ones position contains 6 digit, the digit 6, and the 10 position contain digit 5, and 100 position contain digit 2. So we can say that if we write the 256 in the position manner, so it will appear as 2 into 10 square plus 5 into 10 to the power 1 plus 6 into 10 to the power 0. So 2 into 100 plus 5 into 10 plus 6 into 1 means 256. This is the actual number. Okay, so this is the decimal number system. So the rightmost digit has the least position value weight, therefore it is called the least significant digit. So the rightmost digit has the least position value, therefore it is called the least significant digit, that is LSD. The leftmost digit has the maximum position value weight, therefore it is called the most significant digit, that is MSD. In the above example, 6 is the LSD and 2 is the MSD. Okay, so now let us consider the decimal number system 49.12. In previous example we have discussed the 256, which was not a decimal number, it was the actual number. But in case in this example we are going to use the decimal number system, the decimal number, that is 49.12. so the decimal point separates the whole number in the left and the right digits. So in right the digits were 4 and 9, in left in right the digits are 1 and 2, and the left the digits are 4 and 9. So here is the positional values. If we consider it as the most significant digit, that is MSD, which is present at the leftmost digit, that means here is the 4 is the MSD, which present in tens position. Okay, and the LSD, that is least significant digits, which is present at the rightmost cell, which is 10 to the power minus 2, that is the. So here if we place the values in cell format, so here we can say that here is 10 to the power 0. The position to the right of the decimal point are called the decimal places, and the digit at the decimal places shows the number of tens. In our example it is 1/10, means the decimal places shows the number of tens, mean 1 is 1/10, means this is 1/10. Okay, this is 1/10, and the next digit, the second decimal places shows the number of hundreds. This is the second decimal places shows the number of hundreds. Okay, so shows the number of hundreds. So and so on. So in our example there are 200s. Okay, so I hope all of you have understood the decimal number system, which contains the 10 digits, that is 0 1 2 3 4 5 6 7 8 9, and what is LSD and what is MSD, what is LSD and what is MSD. So in binary number system, the computer system is designed on the binary number system. So the binary number system has a base of 2. It has only 2 digits, that is 0 and 1, and can represent any character with these 2 digits. Okay, as we already discussed that computer works in binary system, so this is most important system for computer. So the computer system is designed on the binary number system. So the binary number system has a base of 2. It has only 2 digits, that is 0 and 1, and can represent any character with these 2 digits. So the binary number system is also a positional numbering system, wherein each binary digit has its own value or weight, which is expressed as a power of 2. So consider a fractional binary system 1011.0101. Positional values weights 2 to the power q. You can see his here is the decimal point, then from right to left, here is 2 to the power 0, 2 to the power 1, 2 square, then 2 cube, and after the decimal unit from right to left there is 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, and 2 to the power 4. So here is the MSD is the leftmost side which have 1, and in the leftmost side it contain left significant digit, that is 1. So in binary system the number should be 0 or 1, but in case of decimal number system we have already discussed, it can be 0 to 9. Okay, so for a binary number, the binary point separates the whole number part from the fractional part. So the place values of the digit to the right of the binary point are obtained by raising 2 to successive negative powers. So the next is octal number system. The octal number system has a base of 8, so it has 8 digit. As we discussed that in binary system it contains only 2 digits, 0 and 1. In decimal system it contains 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but in octal number system it contains 8 number. These are 0, 1, 2, 3, 4, 5, 6, 7. If you count 0, 1, 2, 3, 4, 5, 6, 7, so here we use 8 digits. Okay, so each digits of an octal number can have any value from 0 to 7. So the octal number is also a positional numbering system. So each octal digit has its own positional values or weight, which is expressed as the power of 8. So as an example, consider 1267.12 an octal number with a fraction. You can see here that here only they used only digits in between 0 to 8. Okay, so if we place it in octal number system with decimal point, so decimal point separates the number in right numbers and the left containing digits. So in this number system, in this number the MSD is 1, which placed in the positional value of 8q, and LSD is 2, which placed in the 8 to the power minus 2. You can see in this figure, that is MSD, and here is the LSD. Okay, here is the LSD and here is the MSD. So as in the decimal and binary number system, the radix point separates the whole number part from the fractional part. So the place value of each digit to the left and right of the radix point is equal to 8 raised to the successive positive and or negative power respectively. The next is hexadecimal number system. So the hexadecimal number system has 16 as per the name hexadecimal number system. Hexa means 16. So the hexadecimal number system contains 16 digits. Okay, 16 base numbers. So it has 10 numeric digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 6 letters. These are A, B, C, D, E, F, which represents, where A represents 10, B represent 11, C represent 12, D represent 13, E represent 14, F represent 15. So in hexadecimal number system, the base numbers are the contains 10 numeric digits and 6 letters. So the hexadecimal number system is also a positional numbering system. So the value of a hexadecimal digit is expressed as the power of 16. You can see in this example, here it is a example of hexadecimal number system, that is 165.C2. So it is the decimal unit, decimal point which separates 165 and C2. So in this hexadecimal number system, A is the MSD and L is the LSD. We have already discussed. So I hope all of you have understood what we have discussed: the decimal number system, the binary number system, the octal number system and the hexadecimal number system. read it in your read it at your home, and if you have face any problem to understand the different number system, then you can ask me, and in next class we will discuss about conversion to decimal number system and conversion of decimal number system to other number systems. Okay, thank you.